This is the computer that I use every day for work. If you want to see what your desktop looks like as a computer engineer, you don't use the regular operating system that everybody else does. So this one has some of my favorite features. So here you can see all of the projects that I'm working on. I am a software engineer, but most of my work involves working on hardware as well. This is a photograph of me in the lab at the main office. So when things are really cooking, as an embedded engineer, your desk kind of looks like this. A little closer look as you make extensive use of oscilloscopes, which is here on the far right. And below that is the device that I'm testing. And here's another, what's called a logic analyzer, which is for checking out digital signals. So you use this to check out analog signals, and you use this to check out digital signals. And all the while, you've got code here on the main screens that you're actually writing code that is influencing the hardware. So you need to find out that what you're doing might be working correctly or might not be working. You're usually here to solve problems. This is about test equipment. So quite often when you're trying to solve issues, in particular, in this particular case, I was trying to solve audio-video synchronization, meaning that when you're watching on a TV or on a player, that the sound from a person's mouth comes out when their mouth opens. It's a classic problem called AV sync, or audio-video synchronization. Sometimes the equipment for testing those isn't available, or it takes a long time to develop. This is an example of one of those. What I did here is I took this little box here, which is a $20 device I got off of Amazon, and I found that the device was not implemented correctly. So I found that there was a chip in there that was giving me signals for the video that I wanted. So what I did is we brought a bunch of wires from that chip out onto the side of the box here, and we hooked them up, and I used them for testing. So you can see the box down here in the corner of this. This is hooked up, and it's monitoring this video player's output. This one box replaces about a $20,000 piece of equipment, which would also take very long to get here. So basically in a few hours, I had this up and running. And the nice thing, and just as an example, I'll show you what the output of this looks like on the oscilloscope. What I do here is I hook up the video traces, and what's happening here is there's an audio signal and a video signal, and I can see the audio signal going in and the video signal going in, and then I can see the audio signal going out and the video signal going out. So this lets me know how the spiky curves in the blue here are the video signal, and that is a flash on the screen. So that's one frame. So if audio and video are perfectly synchronized, you get these two guys, the top two lines, that they're perfectly aligned together. You can see the lower two lines. This one is delayed by almost a full frame, and this one is arriving a little bit early. I'll just show my workbench and some examples of things that I've done with it. All right, here's an example of some things that I've designed. This is like one of my first musical instruments. So I just used a box for wires that I had. If you notice, I put pieces of copper out here. I open this and I run the wires down to this little computer. And so this is like a little maker project. But basically what this does is it turns this box into a musical instrument. Other things that I've done, there was a time when I was doing a lot of flight simulator stuff. So this is a box I put together. It's just a regular kit box, but I use this to control the navigation and autopilot of the flight simulator program. So this took me, it was about an 8-hour project. I did have to write some code to get it to work, but it was pretty straightforward.